Example question 37. Using the data in the result table, calculate the change in position for each time interval. Record the change in position in the change in position column of the table for experiment. So here you have an experiment for free fall where you have image exposure number, the time at which the image is taken, and the corresponding position values. From these position values, you need to find the change in position in each time interval. And the question has given you the hint that the change in position for each interval is calculated by subtracting the previous position from the current position. So I can find my change in position delta x by taking a difference of the current position and the previous position. So current position is the position value at which you are finding your delta x. So if I'm finding change in position at time interval 0.1 seconds, this becomes my current position. And the previous position is the position value before it. So for now, my previous position is 0. So if I'm finding delta x for this particular time interval, I will write the current position 0.06 minus 0. That gives me the final answer to be 0.06. Similarly, we do the same thing for the next time interval. I take the current position, which is 0.18, minus the previous position, which is 0.06. And when you solve this, you get the change in position to be equal to 0.12. Then we repeat for the next time interval. Here, my current position is 0.42. My previous position is 0.18. So when you subtract 0.42 minus 0.18, you get the change in position to be equal to 0.24 meter. So I write here 0.24. This is part A of the question where we are just finding the change in position values. So repeat the same steps for all the other position values to get the individual change in position for that particular time interval. And when we do that, these are the values for change in position that we get. This is part A of the question where we are just calculating the change in position in the time interval. In part B, the question is asking us, using the data in the result table, calculate the average velocity during each time interval using change in position and the time interval for each measurement. So now we need to calculate the average velocity in the last column. We know that average velocity v bar is given as change in position over the time interval. And we already calculated the change in position in part A, which is in the second last column. Now, what is my time interval? Time interval is the difference in the successive time values. So I can write this as T2 minus T1. Or similar to what we did in part A to calculate delta x, delta t again you can find by taking the difference of the current t value with the previous t value. When you take the difference in the successive time values, you will notice that the difference remains the same. So let's say if I subtract 0.1 and 0, you get the time interval to be 0.1 seconds. Then I do the same thing for the next consecutive value. I subtract 0.2 and 0.1. That again gives me 0.1 second. Try the same thing with the next two values. You do 0.3 minus 0.2. That gives me again 0.1 seconds. So your time interval delta t remains the same throughout the table, which is 0.1 seconds. So if I want to find my average velocity, I need to divide my change in position value with the time interval delta t, which is same for all the values and it is 0.1. So all I'm going to do to calculate average velocity is divide the values in the second last column, which is the change in position, with 0.1. And when you do that, when you divide each value with 0.1, you will get the average velocities. So let's divide 0.06 with 0.1. divide by 0.1. That gives you the average velocity to be equal to 0.6 meter per second. Do the same thing with 0.12. Divide this by 0.1. You will get the velocity as 1.2. Then do the same thing with the next one. Divide this 0.24 by 0.1. The average velocity becomes 2.4. So repeat the same steps for the rest of the values of change in position to calculate average velocity. And when you do that, you get these values for your average velocity v bar. So this completes part B of the question. In part C, you need to plot a graph between the calculated average velocity and time. And then we have to draw a line of best fit. So these are the time values and the values of average velocity. We need to plot a graph using these two values. Now, when you're plotting a velocity versus time graph, the time values will come on the x-axis, whereas velocity values will be on the y-axis. So when you plot a graph of this velocity versus time values, you get a graph that looks like this. When we are plotting a graph, we need to remember certain important points. First thing is always write the title of your graph. The title could be a simple explanation of what you're plotting, like velocity versus time. Then label the axis. Here, my x-axis is time, so I write it as time with the unit seconds. On y-axis, we are plotting velocity, so I write velocity with the unit meter per second. Next is to write down the values on the axis, and these values of time and velocity must have the same interval. That means when I take difference between any two successive values, that difference must come out to be the same. So if I subtract 1.6 with 1.4, the difference comes out to be 0.2. Then if I subtract 1.2 to 1, again the difference comes out to be 0.2. So this difference between any two consecutive values must be the same. So how can you determine what range you should be using and what should be the interval on your axis? Look at the readings of your table. My time values goes from 0 to 1.6. So there are around 16 values over here that I need to plot on my graph. If I want to plot 16 value, taking an interval of 1 unit will be very long. So I take every single block to be equivalent to 0.2 seconds. So every single point on my axis is 0.2 seconds. You start from 0, 0.2, 0.4, and so on. Do the same thing for velocity values. Your velocity values are going from 0 to 15.6. So my range again can be from 0 to 16. Again, I cannot put all the 16 values on the graph, so we can take the difference or the interval to be equal to 2 meter per second for velocity. So I will progress on my velocity axis with an interval of 2 meter per second. We start from 0, 2, 4, 6, and so on. After you plot the point, then we draw the line of best fit. The line of best fit is a line that passes closer to majority of the points. It is okay if it doesn't pass through some of the points on the graph. It must be closer to majority of the points on the graph. And if some points are outliers, like if some point lies outside of your line of best fit, you can ignore them. Just make sure it passes through maximum or closer to maximum of the points. So this is how you draw velocity versus time graph. Make sure you label the axis. Your graph has a title. The intervals along the axis remains the same, and draw the line of best fit. Part D of the question is asking us, use the velocity time graph to determine g at the unknown location. Show all the working. Now g is nothing but acceleration due to gravity. And if I have velocity versus time graph, I can find this acceleration by taking the slope of the graph, because I have velocity and I need to find acceleration from that velocity. And to find acceleration from velocity, we take slope of the graph. So we can choose any 2 points on the line of best fit. Remember, when you're calculating the slope, you have to take the point on the line of best fit, not outside of it. Do not choose 2 points from your table. Choose the point which are on the line. So I will take 2 points on the line of best fit. I'm going to select this point over here and the second point here. You can choose any 2 point and call it as x1, y1. Second point will be x2, y2. So we know that slope is equal to y2 minus y1 over x2 minus x1. So now let us determine the values of my x1, y1 and x2, y2. x1 over here is 0.4 and y1 is 3.60. x2 on the other hand is 1.5 and y2 is 14.40. Now these values I got from the table because the point that I chose were both on the line of best fit as well as on my table. So if you have points which are on both the line of best fit as well as your table, you can select those points. But if you have no points which are on the table and your line of best fit, always select any point on the line, not from the table. So now we substitute. y2 is 14.4, y1 is 3.60 over x2 is 1.5, x1 is 0.4. And when you solve this, you get the value of g to be equal to 9.81 meter per second squared. In this part, the question was asking you to find acceleration, that is the value of g. So we took the slope of the graph. But maybe the question can also ask you to determine the displacement delta x. If they ask you to determine displacement delta x, then you will have to take the area under the graph. So be careful what the question is asking you to find. If we have to go from velocity to acceleration, then we take the slope. But if we have to go from velocity to position values or displacement value, then you have to take the area under the graph.